We're barreling through the Milky Way at over 500,000 miles per hour. Our home is just a tiny pocket of space on the edge of a galactic arm. And while we have gas giants and rocky worlds, 99.8% of our solar system's mass is concentrated in a single object, our engine of life, the Sun. The life of a star is a constant tug of war. Gravity is fighting to crush the star inward, while nuclear fusion is pushing it out from the core. When a star runs out of fuel and collapses under its own weight, it's called gravitational collapse. There's a common myth that our sun will eventually become a black hole, but that's not true. To collapse into a black hole, a star needs to be about 20 times more massive. Our sun simply doesn't have the gravitational muscle to reach singularity. Here is the real timeline. Right now, it's a yellow dwarf. In 7 billion years, the balance will break. The sun will expand into a red giant, swelling up to 250 times its size and swallowing the inner planets, perhaps even Earth. The final result? A white dwarf, a dead, Earth-sized core like Sirius B. This core will be incredibly dense. A single teaspoon of its material would weigh 5 tons. But even that isn't enough to crush matter into an infinitely small point. Naturally, a black hole won't form here. But what if we break the rules? Today, we're skipping the destruction and asking, what happens if we replace our sun with the smallest black hole in the universe? But before we delete our sun, let's meet our main character. We are traveling 1,500 light-years away from Earth to the V723 Monocerotis system. Hiding right here is one of the leading candidates for the lightest black hole in the universe. Astronomers simply call it the unicorn. We can't see the black hole itself, of course. It weighs as much as 3 of our suns, but its Schwarzschild radius, its event horizon, is only about 9 kilometers across. Just think about that. The mass of 3 entire stars crushed into a sphere smaller than an average Earth city. So how did we find this invisible 9-kilometer speck? We found it because of its neighbor, a star called V723 Mon A. In mass, this star is very similar to our sun, but the similarities end there. It is bloated and diffuse. Its volume is 11 times larger than the sun's. But the craziest part is its shape. It's not round. The gravity of the tiny but incredibly dense black hole is so strong that it is literally stretching the giant star. It warped it from a perfect sphere into a giant cosmic egg, or a rugby ball. It was through this bizarre dance and shape distortion that astronomers figured out an invisible monster was lurking nearby. You might be wondering, why can't we use an even smaller black hole for our experiment, like one with a mass of Earth or the size of a football? It all comes down to the brutal mechanics of their birth. Most black holes are born from supernova explosions. For the core of a dead star to tear through the fabric of space and collapse into a black hole instead of a neutron star, it has to overcome a strict physical barrier, the Tolman-Oppenheimer-Volkoff limit. This limit sits somewhere between 2.2 and 3 solar masses. If an object's mass is any lower, the immense pressure of degenerate neutrons will simply stop the collapse, and a black hole will never be born. The unicorn is the absolute minimum that nature allows. And this exact city-sized black hole is what we are about to place right in the center of our home solar system. Before we destroy our system, let's grasp the scale. Here are all the planets of the solar system, and let's compare known black holes to the worlds in our cosmic backyard. The smallest black hole is the unicorn. Its radius is only 9 kilometers. It is physically smaller than any of these planets. It's smaller than the Moon, smaller than Pluto, and even smaller than the city of Moscow. But in mass, it equals 3 of our suns. It is compact death. But the unicorn is just a tiny minnow in the ocean of gravity. Let's put it up against the true heavyweights of the universe. Meet Sagittarius A star, the heart of our galaxy. Its mass is 4 million suns. Its radius is 12 million kilometers. If placed where our sun is, its dark surface would reach 30 times farther than the moon. But by cosmic standards, this is still a middleweight. This is M87 star, the very same black hole we first saw in a photograph in 2019. Its mass is 6.5 billion suns. It is so massive that it wouldn't just swallow the sun, it could fit our entire solar system inside it, all the way past Pluto and the Kuiper Belt. But even this is not the limit. Finally, TON 618, an ultramassive black hole. Its mass is 66 billion suns. Its radius is nearly 400 billion kilometers. Light, the fastest thing in the universe, would take weeks just to cross its event horizon. Compared to this monster, our unicorn is not even a speck of dust. It is absolute nothingness. But it is exactly this little one that will now decide the fate of our Earth. Let's head home. If we replaced the Sun with a black hole of exactly one solar mass, the orbits of the planets wouldn't change at all. The gravity would remain exactly the same. Someone would have just turned off the lights. But if we replaced the Sun with a black hole of 3 solar masses, tripling the mass of the central object instantly destroys the gravitational balance of the entire system. The current speeds of the planets simply won't be enough to keep them in their familiar circular orbits. Darkness is born. But you know what the most terrifying part is? On Earth, no one would even know. There is no panic. It's just an ordinary Tuesday. Because gravity and light travel at the exact same speed, humanity has exactly 8 minutes and 20 seconds of normal life left. The final rays of light are still traveling towards us through the void, even though their source no longer exists. And then, time runs out. The sky instantly turns black. The moon vanishes. With no sunlight left to reflect, eternal night has fallen. Exactly 1 month has passed since the lights went out. We are alone in the freezing void. You would expect that without the sun, Earth would freeze solid instantly. But look at the sensors. Global temperatures have only dropped by a few degrees. A liquid ocean is still splashing at the equator. Why are we still alive? Because our planet is a giant cosmic thermos. For billions of years, the oceans absorbed the sun's blistering heat. And now, this colossal mass of water acts like a battery, slowly and desperately releasing its residual warmth into the cooling air. And our dense atmosphere acts like a blanket, keeping this heat from instantly escaping into the vacuum of space. The first month in the dark is not death. It is a deceptively warm, endless autumn night. Humanity is still holding on, huddled around nuclear reactors. Exactly 1 year has passed, the sun is gone, and our Earth is drifting along a strange, elongated orbit around the invisible unicorn. Look at the surface. The continents are dead. Europe, Asia, America, they are all giant glaciers now. The average temperature on the planet has plummeted far below zero. The land, unable to hold heat for long, was the first to freeze. Snow has stopped falling because there is no moisture left in the frozen air. But look at the oceans. They are not frozen. It is a terrifying sight. Blindingly white continents and an endless black liquid abyss between them. How is this possible at sub-zero temperatures? The answer is simple: salt and pressure. Salt water doesn't freeze at zero. It requires much lower temperatures. Furthermore, the massive volume of water still guards the last remnants of solar heat in its depths. Right now, on the surface of these black oceans, monster ice storms are raging in total darkness with no moonlight under the gravitational crushing force of the black hole. Earth is still resisting, but the oceans are the last bastion. Once they surrender, the planet will become a perfect, dead sphere of ice. Exactly 1 century has passed. The grace period is over, and the cold has finally won. The average temperature on Earth has crashed through minus 200 degrees Celsius. The oceans have frozen solid for miles down. But the most terrifying thing happened to our sky. At these extreme temperatures, gases stopped being gases. Our atmosphere literally froze. Oxygen and nitrogen turned into liquid, and then fell onto the icy surface as pale, toxic snow. The sky above Earth is now perfectly transparent, revealing a brutal, freezing cosmos. 100 years later, the temperature on Venus has plummeted below minus 100 degrees. Very soon, its thick, acidic clouds will rain down for the last time and turn to ice as well. 500 years have passed. The orbits of all the planets in the solar system have finally stabilized. Earth is covered in miles of solid ice. It seems like an absolutely dead world. But that is an illusion. At the very bottom of the Earth's oceans, tens of miles beneath the ice, life is actually booming. The Earth's core is still blazing hot due to the decay of radioactive elements. Down in the darkest depths, geothermal vents, known as black smokers, continue to erupt. For millennia, bacteria, crabs, and tube worms have thrived around them. Their ecosystem is built on chemosynthesis, not photosynthesis. They never needed sunlight in the first place. Right now, while the continents are frozen to the core and the X-ray disk of a black hole shines in the sky, these creatures continue to live, multiply, and evolve. They haven't even noticed that the sun is dead. Earth has transformed into an icy cosmic ark, a frozen spaceship that will protect this secret life for billions of years to come. Billions of years later, millennia have passed and the system has found its grim peace. But are black holes eternal? Actually, no. The famous physicist Stephen Hawking proved that black holes also evaporate. They slowly emit particles. This is called Hawking radiation. Our tiny unicorn black hole will lose mass. However, for a black hole of this size to completely evaporate, it will take not millions, nor billions, but unvigintillions of years. That is a 1 with 66 zeros. When that time comes, the black hole will end its life with a blinding flash of radiation. By that point, all the other stars in the universe will have burned out long ago, and our Earth, if it somehow survives for these trillions of years, will finally be left in absolute, endless void.